Have you ever wondered how the infinite universe we gaze upon every night came into existence? It's a question that has intrigued thinkers, philosophers, and scientists for centuries. It's a question that takes us back, way back, to the very beginning of everything. Consider this: before the universe as we know it, there was, well, nothing, no matter, no energy, no space, just a singular point of infinite density existing in a state of singularity. But then, around 13.8 billion years ago, something extraordinary happened. This point, smaller than the head of a pin, exploded in an event we now call the Big Bang. Now, when you think of an explosion, you probably imagine a fiery blast, debris flying everywhere. But the Big Bang wasn't like that. It wasn't an explosion in space. It was an explosion of space. From this cataclysmic event, all matter, all energy, and most importantly, space itself was born. As the universe began to cool down after the Big Bang, particles of matter started to form. Over time, these particles grouped together to form atoms, then stars, and eventually galaxies. But here's the key. As all of this was happening, space was expanding. It was growing, stretching out, and it still is, even today. This expansion of space is something we can still observe. When we look out into the cosmos, we see galaxies moving away from us in every direction. It's like we're in the center of a cosmic balloon that's being inflated, pushing everything further and further apart. So when we gaze up at the night sky, we're not just looking at stars and galaxies, we're looking at a cosmic tapestry that's been woven over billions of years. From the fabric of space itself, from the tiniest subatomic particles to the vast complex structures of galaxies, everything we see is a testament to the birth and evolution of space. So, the birth of space is tied to the birth of the universe itself, an event that took place around 13.8 billion years ago. Did you know space is not a static entity, but it's constantly expanding? Let's dive into the concept of space expansion. It's a mind-boggling idea that space, as vast as it already is getting even larger. But how did we come to understand this? The discovery of space expansion is a fascinating tale of scientific observation. Back in the early 20th century, astronomers began noticing something peculiar about distant galaxies. Their light, when observed from Earth, was shifted towards the red end of the spectrum. This phenomenon, known as redshift, provided the first clues to the expansion of space. But why does this redshift occur? It's all about the Doppler effect, the same principle that makes a car's engine sound different as it approaches and then passes by. When a galaxy is moving away from us, its light waves stretch out, becoming redder. The farther the galaxy, the greater the redshift, indicating that it's moving away faster. This led to a stunning realization. The universe is expanding. Now you might be wondering what's pushing these galaxies apart. Enter the mysterious force known as dark energy. Dark energy, despite its ominous name, is simply the term scientists use for an unknown form of energy that seems to permeate all of space, driving its expansion. It's like an invisible force field that's stretching space itself. Here's where things get even more intriguing. Space isn't expanding into anything. It's the space itself that's growing. Picture a loaf of raisin bread dough in the oven. As the dough expands, the raisins move farther apart, but they're not moving into the surrounding air. Rather, it's the dough itself that's growing. Similarly, galaxies aren't moving through space. They're being carried along as space itself expands. So, space expansion isn't about galaxies rushing away into some outer void. It's about the fabric of space itself stretching and growing, driven by the enigmatic force of dark energy. In simple terms, space is like a cosmic balloon that's constantly being blown up but never pops. So, what does the future hold for our ever-expanding universe? As we gaze into the inky abyss that is our cosmos, we can't help but wonder about its ultimate destiny. There are several hypotheses about the future of space, each as awe-inspiring and mind-boggling as the next. Let's explore a few of these fascinating theories. First up is the Big Freeze scenario. This is based on the premise that the universe will continue expanding at an ever-increasing rate. As galaxies drift further apart, the stars will burn out, leaving a dark, cold universe essentially frozen in time. Imagine a cosmic winter that lasts forever, an eternal night where no new stars are born. Next, we have the Big Rip. This theory suggests that the universe's expansion isn't just continuing. it's accelerating. If this acceleration continues unchecked, it could eventually become so powerful that it tears everything apart, from galaxies and stars to atoms themselves. Picture a cosmic tug of war, where the fabric of space-time is the rope and the universe is pulling from both ends. Finally, there's the Big Crunch. This hypothesis proposes that the universe's expansion will eventually slow down and reverse, causing everything to collapse back into a single point. It's like rewinding the Big Bang, a cosmic implosion that might even lead to another universe being born in a new Big Bang. But remember, these are just theories. They're our best attempts to understand what might happen based on what we currently know. As we delve deeper into the mysteries of the cosmos, these predictions may change. After all, space is a grand cosmic stage where the laws of physics dance in ways we're only beginning to comprehend. No matter the outcome, the exploration and understanding of space remain one of the greatest adventures of humankind. So, to sum it all up, we've journeyed through the infinite expanse of the universe, from its fiery birth in the Big Bang to its relentless expansion. We've explored the concepts of dark matter and dark energy, forces that not only fuel this expansion, but also contribute to the formation and structure of space itself. We've also peered into the uncertain future of space, contemplating scenarios from heat death to the Big Crunch. This journey underscores the importance of continued exploration and learning. There's so much more we don't know, so many mysteries still waiting to be unraveled. The story of space is a grand cosmic tale, and we're all characters in it. This understanding should inspire us to keep probing the depths of the cosmos, to keep asking those big questions. Remember, we are all part of this grand cosmic story, and every discovery brings us one step closer to understanding our place in it. Until next time, keep gazing at the stars. Thank you for joining us on this cosmic journey through the cosmic canvas, formation of space. If you've enjoyed this expedition through the cosmos, be sure to hit that like button and share the video with your fellow space enthusiasts. Don't forget to subscribe and turn on post notifications to stay updated on our future voyages. Until then, keep your curiosity alive and continue exploring the universe with us.